So here we have linear functions. These are functions that graph lines. There's different ways to represent a linear function. This way is called the general form. He actually looks really close to standard form, which is probably what you're more familiar with. Standard form, which is ax plus by equals c. These two ones right here are special, and actually these are the ones that like to stump people. If it's x equals, it doesn't have a y, that means it's vertical. Now I remember that it's vertical because it has an x-intercept. Now we don't know what a is, and so I'm just going to graph an arbitrary vertical line, and we're going to say that's at a. Okay? It crosses the x-axis. It has an x-intercept. A horizontal line, will that cross the x-axis? No, no, and this is kind of obvious. It says x equals this, and so that means there has to be an x-intercept. All right, the y is a different story. That one is horizontal. Why? Because y equals it. So we'll say this is b right here. Y's are horizontal. Then you have your y equals mx plus b. You guys remember that's the slope, the m, and that's the y-intercept. I remember it's the y-intercept because if I plug in 0 for the x, which is what all y-intercepts have a 0 for the x. If I plug 0 for the x, then the m goes away and y equals b. So there's your y-intercept. And then we have Big Daddy, or aka point slope form. That's probably the more academic name. I like calling it Big Daddy because you can plug things into this, a point, which is x1, y1, and then the slope, and then you can get standard form, or you can get slope-intercept form. You can get the other forms using Big Daddy. Big Daddy, I think, is more, he's bigger, but he's more basic, and he's easier to use. And then this one right here is just a really complicated way of looking at Big Daddy. Instead of putting m, they put the formula for m. Okay, and I hate the formula for slope because people are always like, oh, is that y2 minus y1? Guys, don't think of the formula. Just think of what it means. Okay, a slope is the rate of change. It tells you the change in the vertical shift and the horizontal. Maybe I shouldn't have said shift. It's the vertical change and the horizontal change. If I were to ask you guys, what is the change from 9 to 16? What would you say?
21.
It's 7. How do you know that? Because you subtract. So all you do is subtract the y numbers to find the vertical change. You don't need to know the formula. But anyways, so let's look at this. What form is this? Okay, what's my point? 9 is first, and -3. You see how this says -9, but this is a positive 9?
Yeah.
That's because the formula is y minus y1 equals m x minus x1. Because it's minus in the formula, so whatever's there is opposite. Oops. Come back. Okay. So that point you can graph. You can graph 9, -3, which is right. See, 1, 2, 3, 4, 5, 6, 7, 8, 9. -3 is right there. So there's 9, -3. Once you have a point on a graph, it doesn't matter if it's the y-intercept or some random point like this one, you can graph the rest of your line. You just have to know the slope. The slope here says -1/3. It says negative and then 1 and 1/3. Okay, you can throw the negative on the 1 or you can throw the negative on the 3. It doesn't matter which one you put the negative on because you'll get the same thing if you use rise and run. Now, if the rise is -1, where do you go? Up, down, left, or right? You go down. If the run is +3, you go to the right. Now, if I look over here at my point, I go down 1, and then right 3, I go off the graph. Okay, so that's no good. So let's try this one. Now, that says +1, up, down, left, or right? Up. And that says -3, up, down, left, or right? Left. The top always goes up and down. The bottom always goes left and right. Let's see. Let's kind of do this one. Up and down, and left and right. That's how you read your slopes. So we're going to go up 1, and then left 3. 1, 2, 3. And so there's our point right there. There's our point right there. Wait, dang it. I didn't go from the right point. Up 1, left 3. 1, 2, 3. I was getting distracted there. Up 1, left 3. Up 1, left 3. And then now you have your line. Okay? Bueno? Questions? Okay, so now let's look at this one. It says graph, and it gives us an equation in standard form. So it's already an a squared plus b squared equals c. Your a is 5 and your b is 2. Sorry, I said squared, huh? Sorry, ax plus by equals c. Okay, let's go ahead and graph it because it's already in that form. Let's graph using standard form. If you graph using standard form, 5x plus 2y equals 12. The way to do it is to use the intercepts, okay? You could really use any number. You could plug in any number, but why would I want to plug in 0? Yeah, it takes away a number, and it's beautiful. When you multiply anything by 0, it just goes away. All right? So I could plug in a 0 to the x. And if I plug a 0 into the x, is that the x-intercept or the y-intercept?
Y-intercept.
Yeah, this is gone. I'm left with 2y equals 12. What is my y-intercept?
6.
So I go y equals 6, which is 1, 2, 3, 4, 5, 6 right there. And then I do the x-intercept. I plug 0 into the y. That goes away. Oh, but now I have to divide by 5, and I get this ugly fraction. So x equals, now, it's really hard to graph an improper fraction, so let's make him a mixed number. How many times does 5 go into 12?
2.
2. And what's left over? 2. Like a remainder of 2, and then you put the 5 on the bottom. And then we graph it. Let's see, 2 and 2/5 would be right after 2, so it's right about there, 2 2/5. And once you have your 2 points, you can draw your line. Connect the dots. Oh, that's a magnificently straight line. Beautiful. Okay, now if you wanted to graph using a slope-intercept form, you're going to have to solve for y right here, because that's what happens. Y is alone. Y is solved for. So the first thing I'm going to do is subtract 5x from both sides, and I get 2y equals 12 minus 5x. Now sometimes people like to put actually most times, people like to put the negative 5x first, but that's okay. You don't have to do that. Then we divide everything by 2, so we get y equals 6 minus 5 divided by 2. We have to write it like this because 2 doesn't go into 5, so now it's a fraction. This one's nice because 2 does go into 12. Now if you want to rewrite it so that you have the mx first, that's fine. You can just go y equals, and you put the negative 5 over 2 first, and then you have plus 6 because that's a positive 6. Okay, and then we graph it. Because you know that this is your y-intercept, this is your y-intercept right there, so we go up to 6. 1, 2, 3, 4, 5, 6. And then from there we do our slope. The slope is negative 5 over 2. Now sometimes it's written as negative 5 over 2, or if you could throw the negative on the 5, or you can throw the negative on the 2. And we kind of went through the differences between the two last graph, so I'm going to choose to do that one. I normally like to have the negative one on top. It's just a preference. It doesn't matter though. So I'm going to go down 5. So down 1, 2, 3, 4, 5. The rise number is on top always. It tells you go up or down. And then my run is a positive 2, so I go 1, 2 to the right. There you go. And you can do it again if you want to. 1, 2, 3, 4, 5, then 1, 2. But you don't have to do it again. And as you can see, we have a line that is exactly the same as that. So it doesn't matter which way you choose to graph it. Just as long as you do it correctly, you'll get the same line.